Welcome to Corporate Finance. Welcome to Chapter 9 of Ross Westerfield and Jordan's Fundamentals of Corporate Finance Homework Solution videos. Problem number 1, we have a series of cash flows and we want to know what is the payback period. This will happen in just about all your companies when you get out there to work. Payback period is very simple to do and very powerful and very useful, so it's used widely. So make sure you know how to do payback period. Minus 7,700 going out in time 0 today, 1,900 coming in. End of year 1, 3,000 coming in. End of year 2, 2,300. End of year 3, 4, 1,700, end of year 4, and our equation is the payback period is the cash outflow minus the summation of the cash inflows. So are we paid back in year number 1? No. Are we paid back in year 2? No. Are we paid back in year 3? No. We're paid back between year 3 and year 4, and we need 0.29411 of year 4. So the answer to number 1 is 3.294117647 years, and I can turn that into days certainly if I want to. If the CFO has a 3-year payback period, your project will get rejected. You will not get the $7,700 you need to kick off this project. In problem number 2, we have project providing cash flows of $835 per year for 8 years. What's the payback period if it cost initially $1,900? How about $3,600? How about if it costs $7,400? How long does it take to pay your CFO back? So since this is an annuity of $835 a year, I can just divide the outflow by 835. So the $1,900, it takes 2.275 years to pay back. $3,600 takes 1.3114 years to pay back. And the $7,400 takes 8.8623 years to pay back. Then you might say never, because another alternate answer might be never, because these cash flows were only coming in for 8 years. And problem number 3, we have Bronco Inc. imposing a cutoff of 3 years. Should they accept Project A or Project B? So Project A costs $40,000, Project B costs $55,000, and then how long will it take to pay your CFO back if you get these amounts of money from them? So you can see in Project A, I'm not paid back in year 1, I'm not paid back in year 2, I'm not paid back till sometime after year 2. So answer 2.4706 years. And if we go down through Project B, which costs $55,000, how long does it take? Same methodology. How long does it take? We are not paid back in year 1, not paid back in year 2, not paid back in year 3. Just between year 3 and a part of year 4, 0.0588 years of year 4. So the final answer is 3.0588. This does not meet the CFO's expectation of three years cut off. But you have to ask yourself, so use a little common sense with payback period and ask the CFO, are you willing to wait 21 days, which is 0.0588 years, 21 and a half days to get a chunk of this $255,000 that'll come in by the end of year 4. So while you may say no, because with a strict interpretation of payback of 3 years, payback cutoff of 3 years, you might want to take a minute and ask the CFO if they're willing to wait about 21 and a half days, and we'll get major parts of that $255,000 flowing in. There are your answers to 1, 2, 3 in Chapter 9. In problem 9.4, project has annual cash inflows of $2,800, $3,700, $5,100, and $4,300 and a discount rate of 9%. What is the discounted payback period at an initial cost of $5,200? How about $6,400? How about $10,400? So basically, we do the same thing we did in the prior problems with regular payback period, but this time we discount them. We discount the cash flows, the first $2,800 by 1.09, the second $3,700 by 1.09 squared, the third $5,100 by 1.09 cubed, and the fourth $4,300 by 1.09 to the fourth. We have a payback remainder, a number of remainder years, and so the answer is 1.845 years. Payback is in years, 1.845 years. Do the same thing for $6,400 outflow, and then when do we pay back? Looks like we pay back between years 2 and 3, and we are at 2.182 years. And then the final one, $10,400. When do we pay that back? We pay that back at 3.26 years. And there are your answers to problem number 4. In problem number 5, you have an investment that costs $19,000, has annual cash inflows of $5,100 for 6 years, $5,100, $5,100, $5,100, $5,100, and so on. What is the discounted payback period at 0%, 5%, and 19%? First, at 0%, there's no discounting, so every $5,100 stays the same, and it only goes 6 years. It doesn't go 8, it only goes 6 years. And it takes 3.73 years to pay your CFO back. If we discount all those cash flows, that first 5,100 is only worth $48.57. The second 5,100 is only worth $46.25, and so on. Looks like it takes 4.23 years to pay the CFO back, and at a very high discount rate of 19%. You can see all the 5,100s are severely discounted in this last column, and it turns out that you don't pay back in 6 years, you don't pay back in even 7 years, but part of the between 7th and 8th year is when you get paid back, when she gets paid back, and the answer might be never. Alternately, you could say that the answer could be 7.08 years. So given that the cash flows only last for 6 years, the answer might be you never pay her back. And in problem number 6, you have given that a new manufacturing plant costs $12.6 million, straight line depreciated to 0, 4 years, straight line. Net income is $1.43 million, $1.523, $460, $1,716, $300, and $1,097, $400. What is the average accounting return? The equation is average net income divided by average book value. I get the average book value by taking the original $12,600,000 investment and bisecting the line, and since it's straight line, if you drew that on an XY axis, you'd see that you bisect the line and the average book value between the two data points is 6.3 million. And my sum of my net incomes, if I add the 1.43, 1.523, 1.716, and 1.097, and divide by 4, I get 1441790, and then dividing average net income by average book value, I get an AAR of 22.89%. There are your answers to problems 4, 5, 6. Problem 9.7, required return is 14%. Should a firm accept the following project with the following cash flows? Today's cash outflow is $41,000. For that, you'll provide the CFO with $20,000, $23,000, and $14,000 coming in. And the question is, what is the internal rate of return? Your hurdle rate or required rate of return is 14%, so we want your project to jump over that hurdle. So for you to get the $41,000 from the CFO, you will have to provide an internal rate of return on your project that exceeds her required rate of return or hurdle rate of 14%. Does your project jump over? The equation is, what is the rate that makes my discounted cash inflows equal to my cash outflow, or where NPV of the project is 0. And you can simply type in this advanced formula, equal IRR, left paren, D92 colon D95 right paren, and you get an internal rate of return of 19.5757%. That does jump indeed over the hurdle inside the company of 14%, and so you will get an acceptance of your project and you will receive the $41,000. That's the good news. The tough news is that you have to go generate $20,000 of cash in the first year, $23,000 in the second year, and $14,000 in the third year for you to have some street credibility with your CFO that you can do this sort of thing. So if you're able to do that, you generate almost 20% return on investment for the company, and your project is accepted, and maybe you get promoted. In problem number 8, for the cash flows in the previous problem, firm uses NPV rule. Should we accept either of these projects at 11% discount rate or at 24%? So first cash flow is still $41,000 per the previous problem. Year 1 cash flow, I just simply take it and divide by 1.11. Year 2 by 1.12 squared, 11 squared, And year 3, divide that cash flow by 1.11 to the third. Do the math. Add all those cash flows, discounted cash flows up, you get 5922.01, which is positive, NPV positive, except at 11%. Doing the same thing for 24%, I take the first year's cash flow divided by 1.24, second year by 1.24 squared, third year's cash flow by 1.24 cubed, and then subtract out from that 41,000, I get a net present value of 2569.77. It is negative, so at 24%, we reject this project. In problem number 9, we see that the project provides cash flows of 15,000 every year, 15,300, 15,300, 15,300 for 9 years. Looks like an annuity to me. This project costs $74,000 today. Your required return is 8%. Is it a good project? If your required return is at 20%, is it a good project? And that's asking what's the indifference rate or the internal rate of return. So at 8%, I write down the words NPV equals, and then I discount the cash flows by 1.08, second one by 1.08 squared, 15,300 by 1.08 cubed, and do that 9 times and see if, with a cost of 74,000, if I have a positive NPV, and it looks like I do. I have, at 8% discount rate, I have an NPV of 21,577. And we accept the project because it's a positive NPV. If I discount the cash flows at 20%, so if your required return is all of a sudden 20%, you discount those cash flows back at 1.12, 1.12 squared, 1.12 cubed, and so on, and subtract out the 74,000, and you get negative 12,326 NPV at 20%. In this case, we would reject the project. What is the point at which I'm indifferent, or the internal rate of return, or NPV equals 0, and that discount rate is 14.6212%. 14.6212, there are your answers to problems 7, 8, 9. In problem 9.10, what's the IRR for these series of cash flows? Whenever you see the letters IRR, you always write down on your piece of paper or your Excel spreadsheet, NPV equals 0 equals minus 18,700 plus 9,400 over 1 plus some rate plus 10,400 over 1 plus some rate squared plus 6,500 over 1 plus some rate cubed. And so you can do that longhand and guess at the rates. Guess and check, or you can type them into Excel and type in this advanced formula, equal IRR, left paren, H115, colon H124, and then a guess at 0.15, and you get a internal rate of return of 20.42%. That is the rate at which your discounted cash inflows will equal your cash outflow, or your NPV equals 0. In problem number 11, we see that we have the same cash flows as problem 10, and we say, what is the NPV at 0? What's the NPV at 10? What's the NPV at 20? What's the NPV at 30? So what we're doing here is creating what's called an NPV profile. So you do the NPV in all these cases. If we discount those cash flows at 0%, we get an NPV of 7,600. If we discount them at 10%, we get 3324. We discount them at 20%, we get 117. Notice we're getting closer and closer to 0. And at 30%, we get a negative 2356. So we see from this NPV profile that the graph crosses the x-axis where NPV equals 0 just over the 20% mark, and from the prior problem we saw that IRR to be 20.42%, so it all fits with the NPV profile. So you can do that solution graphically, you can do it in Excel, you can do it on your scientific calculator, you can do it on your business calculator. The business calculator, you're going to push, instead of compute IRR, you're going to push the buttons IRR compute in that order. Why? Because that's how it was programmed into the BA2 Plus, for instance, on your financial calculator. In number 12, we have Bruin Inc. with 2 projects to choose from. Which is better? 2 mutually exclusive. We only have $41,300. Can't do both of them. We can only do one, so which one should we choose? So there they both are, with $41,300 going out at time 0, and then differing amounts coming in years 1, 2, 3, and 4. So the question is, which project should we choose? And given that they're mutually exclusive, they might have a crossover point. So we're going to take column B minus A and calculate those deltas and then do an IRR on that third column. First, we're going to calculate the IRR for cash flows A. It is 19.7486. That's the discount rate, where if I discount those cash inflows, it equals my cash outflow of 41,300 and NPV is 0. For project B, that IRR is 18.7517. Again, I can use the equal IRR formula to solve for that. What is the NPV at 11%? So I just discount all those cash inflows by 1.11, 1.11 squared, 1.11 cubed, 1.11 fourth, and I come up with an NPV at 11% for project A of 7,001.54, and for project B, I get an NPV of 8948.59, and I see in this case, whereas using the IRR decision rule, I would choose project A because it jumps over the company hurdle rate better. Again, because these cash inflows are all unknown. We know what the project costs today, $41,300, but in both cases, those cash inflows are all unknown. So in the IRR decision rule, we want to select the project that jumps over the hurdle better. And that's cash flow project A. And if we look to the NPV rule for project B, we want a positive NPV, but we want the most positive NPV, and at 11%, that turns out to be project B. So here you're getting two different answers to tell the CFO as to which one is the best. Now, in doing NPV of B minus A and doing an IRR on B minus A, I get a crossover rate. So if you were to graph these two projects on an NPV graph, you would see that the two lines cross over at 16.36%. So we would pick B at lower rates, project B, and then we pick project A at every rate after 16.36%. That's the advantage of, so be careful. One thing we learned from this is be careful with mutually exclusive projects. Can't do them both, but they might have a crossover point. And as I said, you can see on this NPV profile from 0 to 20% that I take project B at lower rates, and then all of a sudden it flips over and I take between 15 and 20%. Right around 16.3624%, I cross over, and then at higher rates, discount rates, I take project A. And there are your answers to problems 9 through 12. In problem 913, we have two projects again, X and Y, and they want you to sketch the NPV profile of both these projects from 0 to 25% discount rate, and do these mutually exclusive projects. They each cost $30,000. Can't do them both. I can only do one or the other. Which one is best, and which one do they cross over by chance if we plot the NPV profile? So we're going to see that they cost $30,000 each, and they spin off different cash inflows, 13.7, 14.2, and 13.4, whereas Project Y will provide inflows of 15.6, 12.2, and 13.3, and which one is the best. So I could do the NPV equals 0 equals IRR on these X cash flows, and I get an IRR of 17.92%. I can do the same thing with cash flows Y, minus NPV equals 0 equals minus 30,000 plus 15,600 over 1 plus sum rate R plus 12,200 over 1 plus sum rate squared, and 13,300 divided by 1 plus sum rate to the third. And what is that magical rate? 18.1654%. So based on the IRR decision rule, I would pick project Y because it jumps over the hurdle rate better. And then I do an NPV profile, and I also do Y minus X. So cash flows Y minus cash flows X, watch your sign. And then I will do an IRR on this last column here, Y minus X. So the NPV profile shows that at low rates of discounting, I take project X, I take project X, I take project X barely. Project X is barely higher, and then after it crosses over somewhere between 10 and 15%, I see that I switch over to selecting project Y, project Y, project Y. These have better NPVs in those last three cases. And what is my crossover rate? I simply do a NPV equals 0 on this last column. NPV equals 0 equals 0 plus 1900 over 1 plus sum rate, plus or minus 2000 over 1 plus sum rate squared, plus minus 100 over 1 plus sum rate cubed. And if I do that IRR, I get an IRR of 10.0459%, and that is your crossover rate on these two projects. Remember to use care when considering mutually exclusive projects. They might cross over and cause some confusion as to which project to choose when selecting NPV. Light sweet petroleum in problem number 14, trying to evaluate a generation project which has following cash flows. Their hurdle rate is 12%. And so we want to look at the cash flows and see what kind of cash flows we have here. And what we see here is non-traditional cash flows, non-conventional cash flows, minus, plus, minus. So you're going into the CFO to ask for $52 million today. For that, you promise her $74 million, and then you're asking her for another $12 million in the second year. Probably not going to make her very happy with these flows as they are, minus, plus, minus. CFO likes to see the following cash flows, minus, plus, 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 plus. We don't see that in this project. So looking at Descartes' rule of sign, how many IRRs might we anticipate? Well, René Descartes says that the number of IRRs in non-conventional cash flow situations like this, the number of IRRs is equal to the number of times the signs change. So here we go, minus 52 to 74. That's one change, and then 74 to 12. Minus 12 makes two sign changes. So Descartes' rule of sign tells us there might be two IRRs, which will really confuse the CFO. There might be one IRR. There might be no IRRs. In this case, we see that the NPV of these cash flows at 12% is $4.5 million. So that would be an accept decision. Accept based on the NPV rule. And we compute the IRRs, NPV equals 0 equals minus 52 million plus 74 million over 1 plus sum rate plus a minus 12 million over 1 plus sum rate squared. And I can do that longhand math, or I can use the IRR advanced formula in Excel. And one of the IRRs hits 0 at NPV equals 0 at 23.64%. If I keep trying, I find indeed a second IRR. So Descartes' rule of sign was correct. There are two IRRs, and the second one's at minus 81.34%. In this case, use the NPV rule, the best method that we've learned. The IRR rule runs into problems with non-conventional cash flows and mutually exclusive projects, as we've seen in the last several problems. So use NPV, it's the best method, but know the IRR, test the IRR, use multiple methods to evaluate these large capital investment projects. Problem number 915, what's profitability index at 10%, 15%, and 22%? This is a method we use in governmental projects or nonprofit institutions if you end up working at one of those venues. The cash flows are minus 14,800, then cash inflows of 8,400, 7,600, and 4,300. And we want to calculate the PI at 10%, 15%, and 22%. At 10%, the profitability index is simply the present value of the cash inflows divided by the cash outflow. It's kind of a benefit to cost ratio, and we get 1.1586 times. That means it has a positive NPV. That means accept the project at 10%. At 15%, same thing. Present value of the cash inflows, discounted cash inflows divided by today's cash outflow, benefit to cost ratio. I still get a positive NPV, so it's accept at 15%. And then finally at 22%, I do the same thing. I take the present value of the cash inflows, discounted cash inflows, divided by today's cash outflow of 14,800, and I get a profitability index of 0.9702, and that is reject. That's because it has a negative NPV. Or a PI less than 1. Notice the trend here. If PI is greater than 1, we have positive NPV. In the case where the PI is less than 1, we have a negative NPV and a reject decision. There are your answers to problems 13, 14, and 15.